Getting this? So anybody else wants to say anything about move instruction? I shown you a example how a C++ statement for assignment operator can be done using move instruction. Yes, anybody wants to say anything about move instruction? What example did I give you for move instruction? So can anybody just give an example? Okay, move x comma 10. What will that do basically? This particular statement in assembly language, what it will be doing? You should give a space, okay, Divya, remember that. After move, you should give a space. It is not case sensitive as such, the instruction, but after the instruction, it is expected that you give a space. Yes? What will that do basically? Move x comma 10. Yes, everybody be involved in the discussion. So Ankita has given an answer. Anybody else wants to say anything about that? So yes, one or two of you are saying that 10 will be stored into variable x. Okay, does everybody agree with this? That is what a move instruction will do for this example? Yes? Yes, be interactive in the class. Yes, Vibhor, do you agree with that? That will store 10 into
Yes,
variable x?
yes, sir.
Okay. Uh, okay. So what move, basically in general what we can say is that the move instruction will store the value of the second operand into the first operand. X is the first operand. There are two operands for move instruction. X is the first operand and 10 is the second operand. So what it will do is that it will store the value of the second operand into the first operand. It is like a parameter operand to the instruction. Okay. So move x comma 10 will store the second operand 10 into the variable x, that is the first operand. Okay. Again speak, yes, another thing about the note, everybody is now aware of that, right? From the 11th the college is going to start. Yes. Yes, is everybody aware, isn't it? What is the circular, Omkar? We have not been communicated with that circular. I didn't read it at least. Maybe I'll have to check that. But as far as till now we are aware of that. Okay, if I'll check that, if anything as such comes, we'll forward it on your group basically. Okay? So you keep in update about in the group basically. But another thing, whenever it will start, in the notice there is a uh, Sahmati Patra, okay? Consent form in the notice. So you should fill it and take sign from fill it from the parents and take sign on it from the parents. So remember that whenever the start date will come, as far as I was concerned, it was till 11th, but I'll check the notice if today anything has come. Okay. So you'll have to take the consent form from your parent and then come to the college. Okay. So that is compulsory whenever the college will start. So remember that point also. Okay. I'll check the notice. If there is any such thing, I'll convey it to you on the group basically. Okay, Omkar? Okay, either way, keep on doing your studies basically. That is for sure that your first sem exams are going to happen after the once the revision is completed. At least we don't know what will be the format and all those things, but start preparing for your first sem exams. Okay? And another thing, complete the submission of the first sem subjects. Though the second sem theory has started, keep in mind that complete the first sem related all assignments, uh, submissions. Again, speaking specifically about OOP, submit the assignment of OOP. I have uploaded it on the Google Classroom. So you have got time now for first sem preparation. So upload the assignment of OOP. Okay. It will be considered in the internal assessment of OOP lab. Okay. So upload the assignment that I have given on the OOP classroom. Okay. It will help you for your exams also, because it will help you to understand what kind of questions come in the exam. Okay. So upload that assignment as early as possible. Also, I have given the PPT link. Many of you have not uploaded the PPT. So upload the PPT of OOP also on the Google Classroom. Okay. And I've also given in the last few days back a link for the mini project. So what is expected is, if you have not prepared any mini project for OOP, you can develop it if you have time, or whatever STL assignment you have done for the laboratory, that can be uploaded as a mini project, because that's an advanced concept. We have taken expert talk also on that. So that can be used if you don't want to have a different mini project. If you are open to you are possible, you can develop a new mini project, you can do that. I'm welcome for that. Okay. So those who can do a new mini project can obviously do that. But those who are not finding it easy to do that, or if are not able to do that, you can upload the STL assignment in that link. Okay. So that will also be minimum acceptable. It is expected that if you do a better one, it is always acceptable, or you can modify that and add some features and do that. Okay. So do upload the mini project also of C++ in the Google Classroom of OOP. Okay. And again, audit course. I didn't check today how many are remaining here, but 2 3 days back at least 10 to 20, 20 to 21 of you were remaining. So please do upload the audit course, because whenever the link comes for its submission, we'll have to give as per your submissions the marks for that audit course. Okay. So be careful. Those who are still remaining, do compulsorily upload the report and feedback of the audit course. Okay, it's part of the syllabus because. Okay, okay. So that is about the first sem. We'll go back to the our subject next second sem subject microprocessor. Okay. So I'll just share with you the syllabus of the practical also. You should be aware of that. So you'll get an idea about what we are going to learn in the theory I discussed in the last two lectures. Practical, I didn't show you any syllabus of it. I'll just show you that also. With that, we have to learn the concepts regarding the practical in the theory also and in the laboratory also. Okay. So theory has both basics of the theory and the practical also. Okay. So I just show you the basically syllabus for the practical. Yes, is the screen visible to you?
Yes, sir.
Okay. See, this is the microprocessor laboratory. Okay. So it has a term work of 25 marks and practical exam of 25 marks. Okay. So the companion course for it is the microprocessor. Course objectives for the microprocessor laboratory is to understand assembly language programming instruction set. So you have to understand the assembly language programming instruction set. So this instruction set of 80386DX is there in the theory part of the first unit. Okay. To understand different assembler directives with example. So you have to use the different assembler directives like macro and all those things. Okay. With examples in the programming. To apply instruction set of implementing x86 64-bit assembly language programs. So you're going to learn about 32-bit and 64-bit assembly language programs. Okay. So that, and you have to apply the instruction set for developing such programs. Okay. On completion of the course, learner will be able to, these are the course outcomes, understand and apply various addressing modes and instruction set to implement assembly language programs. So understand and apply addressing modes of the processor and instruction set that we have studied to implement assembly language programs. Apply logic to implement code conversion. So 32-bit program will have to be converted to 64-bit program. So how to do that? All those things related to code conversion also you need to understand. Okay. Analyze and apply logic to demonstrate processor mode of operation. So we have a program which identifies in which mode the processor is working. So that also you can demonstrate using assembly programming in the microprocessor lab. Okay. So these are the course outcomes that are expected from this subject. Okay. So basically there are four other, yes, one is study assignment, 14 assignments are given, and out of that you have to basically write any 10 assignments, develop any 10 assignments. Okay. So the first assignment is write a x86 64 ALP to accept 64-bit hexadecimal numbers from user and store them in an array and display the accepted numbers. So reading the basically five numbers, hexadecimal numbers, and store them in array and display the accepted numbers. Okay. Then write an x86 64 ALP to accept a string and to display its length. This is another string related assignment. Then write an x86 64 ALP to find the largest of a given byte, word, double word, 64-bit numbers. So you have to find the largest of a number from a list. Okay. Then write a switch case driven x86 64 ALP to perform 64-bit hexadecimal arithmetic operations using suitable macros. Define procedure for each operation. So this is a program for arithmetic operations for 64-bit hexadecimal numbers. Then write an x86 64 ALP to count number of positive and negative numbers from the array. So you have to find out the positive and negative numbers from an array. So are you getting what I'm just going to discuss few assignments in just introduction of it. Are you getting what kind of programs you have to write in the laboratory? So they are basic, but in assembly language the code size is large for even doing the basic things. And some programs are even advanced at a level, okay? So basically you will have to not only learn assembly language but write programs in assembly language, particularly 64. They have mentioned that you can use 32-bit also, but we are going to write all programs in 64-bit assembly language because that is expected by the university. Okay. So most of the programs that we are going to write are going to work on your latest processors. Okay. So these are some of the programs. I just discussed a lot of programs are there. Positive, negative. Then sixth is hexadecimal to BCD and BCD to hexadecimal conversion of numbers. Okay. Then next program is to detect whether the processor is running in the protected mode and to display GDTR, LDTR, IDTR, TR, MSW registers. Also identify CPU type using CPU ID instruction. Okay, so this is a low level program. This is an advanced program. Okay, then assembly language program. ALP means what? Assembly language program to perform non-overlapped block transfer without string specific instructions. Okay, then x86 64 ALP to perform overlap block transfer with string specific instructions. Okay, then x86 64 ALP to perform multiplication of two 8-bit hexadecimal numbers. So multiplication of two numbers, you have to write code for that to implement the method for the multiplication. Successive addition and add and shift method. Okay, use of 64-bit registers is expected. Then write x86 assembly language program to implement following OS commands: copy and type using file operation. User is supported to provide command line arguments. So whatever you write in DOS, copy, type commands, for that you have to write an assembly language program to support those features using our program. Okay. Yes, are you getting an idea what kind of programs are there in assembly language for our syllabus in practicals? So lot of programs are there, new language is there for you. So you'll have to take effort. Remember, I can tell you almost from the last few years, I have an experience about the programming is that many people are not able to run the program in the exams. So please don't let that happen to you. Take effort for the programming. Okay, because if it doesn't run in the practical exam, what will happen is that then it depends on the oral and so many factors whether you will pass the exam or not. So let's not let that happen to any of you. Okay, because I've seen that from last few years this subject is there. Many students find it difficult to get the output of the program. Okay, though we take a lot of effort for them to understand it, many of them do it also. I'm not saying everyone doesn't run it, but many people find it difficult to complete the program and run the program. I hope this time it doesn't happen. Okay, so take effort, that is what I'm trying to tell you. Okay, as compared to C++, this language is more difficult because you're not aware of it, anything about it. Okay, so take effort. If you take effort, you will find it very easy. As such, if you know this language, it is very easy. But if you don't study, then you will find it difficult. Okay, so take effort for this subject, both for theory and practical. Okay, obviously, I'm not saying that you stop the first sem exam studies, because first you have exam of the first sem, so we are going to study it later also after you complete the first sem exams. But just because we are having the lectures of the second sem going on, I'm giving you an idea of the subject and the practical. Okay. Any difficulties so far anybody has? Anybody wants to ask anything? Yes, feel free if you have anything to ask about the syllabus of the practical, anything specific, or about the theory we have discussed so far. Most probably this semester will go on offline, so you'll find it better to study the practicals as such. Theory both online and offline is you are comfortable with that, but particularly about the practical, it is difficult for you to study online, isn't it? So you'll get a chance to sit in the laboratories and do the practical programming. So that will be more helpful for you, let's say in this sem maybe. If it starts, I'm not sure because new notification somebody said. But whenever it starts, you will find it easy for the programming part. Theory, either way, we are doing that online also. Theory also offline mode, maybe you will find it more easier if it starts. Okay. Yes, any difficulty about the practical syllabus? Anybody wants to ask any question specific to practicals? Earlier it was a 50 marks practical and 25 marks term work. Now they have made it 25 marks practical and 25 marks term work. Okay. Yes, anything, anybody wants to ask anything? Okay. Don't worry about it, but take effort. Because I don't want you to be that, okay, it will be easily happening, because I'm telling you the experience, because we are there during the exams of this subject. So we observe that many students don't are not able to generate the output. So it becomes a very difficult situation in front of the external. Okay, so I'm just warning you so that you take effort right from the first day. Okay. So because many students they don't complete the practical, and then it depends on the oral and what the external things and all those factors start coming into picture. Okay, so we don't want that. If you run the program, very good chance that you are going to get good marks. If you give the oral, at least you're going to pass, that becomes sure. And if you give the good oral, you'll get score also in the exam, practical exam. So be careful about that. Okay. So see to it that you keep an objective that your program will run in the exam of the microprocessor laboratory. Okay. I think they are little bit simplified the syllabus as compared to the old syllabus. So that will help you, because earlier there were these programs, some of them were part of a single assignment. Now they have divided the assignments of that particular program. They have kept the syllabus is same as the previous syllabus almost, but a little bit simplified the programs. So that will maybe help you in the exam. Okay. Okay. Just giving you a feel of the practical, I just show one of the programs that you have in the syllabus, just to give you an idea about how the assembly language programming does done and how the instructions are used, because I'm going to start discuss in theory about the instructions, so you can see how a program uses the instructions directly first hand. So I just share with you a program. Okay, so this is a program in assembly language, basically to count positive and negative numbers in an array. Okay, so you can see here the array has been declared. So it is different than how you do it in C++. Array is the variable name and DW is the defined word data type has been defined and values have been put into the array. Then there is a macro for print. Look how many steps you have to give for printing something. In C++ you are going used to just say cout. But in assembly language, every small thing has lot of code to be done for doing the functionality. So for print, there is a macro written. So every time you want to print any string, number, anything, you have to use this code for printing the uh, whatever value you want to print. Okay. Then just like you have a main, you have a global underscore start in assembly language. So you can see move instruction we discussed in the last lecture. How move instruction is a lot of places used for writing the assembly language program. Move RAX comma 1. So as you know, second operand is stored in the first operand. So what move RAX comma 1 will do is that one value will be stored in RAX. Move RDI comma 1. What it will do? Store 1 into the register RDI. Okay, this is a register basically. RAX, RDI, RSI, RDX are also registers. Okay, so using assembly instructions, you have to write such programs. Okay, so I'll not go into too much of the logic of the program. I just want to show you an assembly language program. See, for displaying, not just the macro is required, but this particular display related procedure is also required if you want to display a number. So look at the additional amount of code you have to write in assembly language. So for displaying a number, this particular code will be used in almost every program of your assembly language. So this is the logic for displaying a number on the screen. Because what happens is that when I want to display 1, you have to store it as 3 1, because ASCII value has to be passed to the displaying macro and then you have to display the number on the screen. So particularly displaying a number is a little bit lengthy process as compared to displaying a string. Displaying of string will have require only one macro required, but displaying a number along with the macro will require this display procedure. Okay, which is using move and add, all different kinds of instructions. Okay, so you can see how instructions are used for writing a assembly language program. Okay, getting this concept. Yes, are you getting an idea about how the assembly language program looks like? I just shown you one program that is part of the syllabus also, called counting the positive and negative numbers in an array. See, I didn't go into too much of the logic because you're not still aware of the instructions that are required for writing the programs. So once you're aware of the instructions, you will find it easier to write the programs. Okay. So I just show few instructions in the program again. So I called about move instruction. Okay. Now look at this instruction. Move ESI comma array. Now here both the operands are basically not constants. ESI is a register and array is a variable. Okay. So that was also possible with move. You can give non-constant operand also as a operand for the move instruction. So what it will do is that array value will be stored into, so particularly you are not using square bracket. So since you are not using square bracket, the address of the array variable will be stored into ESI. If here instead I would have used square brackets and array, what would have happened is the value at the array location would have been stored into ESI. But since I want to store the address of array, I am not using square brackets. Okay. So the value of the address of array will be stored in ESI. Again, move ECX comma ARR count. Here I should have used square bracket actually. Okay. So what you could have done is that square bracket array count will store the value of array count in ECX. ECX is a register, 32-bit register. Okay. Then JNC P next, PNXT, this instruction. Look at this instruction. This is a conditional jump instruction. Okay. Jump if not carry. If there is not carry flag is not set, jump to the label P next. So this is a label P next here. Okay. So jump to this statement. So I'm just showing you the fields of the instruction. Okay, I'm just showing you how the instructions are used in assembly language. Then we'll discuss about the instruction set. This is an actual example of where you have to use the instructions. Okay. So a lot of instructions have been used. INC, increment. INC is what instruction? Increment instruction. What INC does is that it increments the value in the operand. So what this instruction will do is that INC ESI, whatever is the value of ESI will be incremented by 1. Okay. Then again move instruction. Move BL comma square brackets PCNT. So what PCNT is a variable and BL is a register. So whatever is the value stored in P count variable, PCNT variable will be stored into register BL. Okay. Yes, are you getting an idea about how instructions are used in a program, assembly language program? I'm just giving you fields of the programming of assembly language. Okay, getting this? So move instruction has been used lot of times in the program. Okay. Then other instructions are also there. That is how you have to write the 64-bit assembly language program. Okay. We'll go into details of that in the practicals when we start studying the practical. But since in the first unit you have the instruction set, I'm just showing you how the instructions in the instruction set are used in the assembly language program. Because you have to study all the instructions in the instruction set. Okay. So I'm just showing you the practical example of that instructions. Yes, everybody is getting an idea of how assembly language program is there. Yes, Kiran. Yes, others. Keshav. See, I know it is not that easy. I can tell that. I'm aware of that, that it's not very simple, but you can gradually learn that. You'll have to take effort for that. See, almost whatever programs you have in the assembly language, I think almost 75% of the programs are already available with me. So problem is not that is to be generated. Problem is you have to understand the code basically. That is what is expected. So almost 75% of the programs of the syllabus are already available and others will also be available. But question is you have to understand the programs. Okay? So no program availability is not a problem, but your understanding of the program is an issue. And obviously you have to learn skills to develop new programs. It is not expected that you take all the ready-made programs and only do that. I will expect from you to write also programs on that. Once you understand the basics, obviously. I'm not going to tell that immediately start writing programs. Once you understand the basics, then it is expected that you also start writing assembly language programs. That is what is expected from you. Okay? See, don't worry because if you study properly, that's not difficult. Okay? Just take efforts for this subject. Okay? Okay, give me a few minutes. I'll just take your attendance. Another thing, tomorrow there will be a coffee katta meeting in the library. Okay? So, again, 5 volunteers will be required for the coffee katta meet in the library. Okay? So, Vibor, have you attended coffee katta meet?
No, sir, not till now.
Okay, then tomorrow I'll put your name in it. Okay?
Yes, sir.
3 o'clock it will be. I'll share the link on the group. Okay? Then, Kiran,
Okay.
have you attended the meet?
Yes, sir.
Okay, Kiran has attended. Shivani, have you attended?
No, sir.
So I'll put your name for tomorrow's 3 o'clock meet, okay?
Yes, sir.
Okay. Then Keshav, have you attended?
Yes, sir.
Okay. What was the roll number last that was basically completed? Does anybody remember? Okay, I'll check that basically. Maybe other three numbers I'll take from the last roll number that was basically completed the library coffee katta meet. Okay? Okay. Yes, so I'll just take your attendance. Omkar, have you attended Coffee Gatta meet?
No,
Omkar
sir.
Tambe?
No, sir.
No, so you attend it tomorrow, okay?
Okay, sir.
Then Divya, have you attended?
No, sir.
So tomorrow your also name I'll put, okay?
Okay, sir.
So tomorrow's link I'll share it, then you can attend the meeting. There is one more volunteer required. Anybody? Then let's say Ankita Kulkarni, have you attended?
Yes, sir.
So your turn has over?
Yes, sir.
Okay. But maybe once the one round is over of all everybody's turn, next round again will come for the next time turn, okay? Mansi Pagare, have you attended? So I'll put your
No,
name
sir.
also tomorrow at 3 o'clock, okay?
Okay, sir.
Okay. You are all aware of what to do in the coffee katta, right? See, about any latest topic or any computer related topic you have read in paper or in some article or in net, internet or any research paper, anything, or you're interested in it, you can speak for 5 to 10 minutes on that in the students group. There is a live meet on the internet, Google Meet, where you have to share about your topic and discuss. All students are there of the college, five students from each class, and you have to discuss with them on that topic. Okay? Okay, everybody's clear with that? What you have to do in the coffee katta? Okay. Okay, roll number 1,
Present, sir.
2, 3, 4,
Present, sir.
Present, sir.
5, 6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11, 12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16, 17,
Present, sir.
18, 19,
Present, sir.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23, 24,
Present, sir.
25,
Present, sir.
26, 27, 28,
Present, sir.
29,
Present, sir.
30, 31,
Present,
30,
sir.
32, 33,
Present.
34,
Present, sir.
35,
Present, sir.
36, 37,
Present, sir.
38,
Present, sir.
39, 40, 41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44, 45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50, 51,
Present, sir.
52, 53, 54, 55, 56,
Present, sir.
57, 58,
Present, sir.
59, 60,
Present, sir.
61, 62,
Present, sir.
63,
Present, sir.
64, 65, 66,
Present, sir.
67, 68, 69,
Present, sir.
70,
Present, sir.
71,
Present, sir.
72. Okay. Thank you for attending today's lecture. We'll continue in the next lecture. Okay. Yes, 71 present, Gayatri.